Well, hello, here we are again. We're taking a look today at the amendments to approved document Part L, Conservation of Fuel and Power. Once again, they've just been updated. The 2013 version came into effect in April 2014. Once again, we have Jeff Wilkinson, Approved Inspector of Repute, Fire Safety Specialist and Arsenal fan, to answer some of our questions and take a look at some of the key points of what's going on in the new documents. So let's just cut to the chase, Jeff, if we can. These approved documents, 2013 edition, for use in England only. So what's that about?
Yeah, you're quite right. What's happened is that the Welsh have adopted their own set of approved documents. In fact, they've adopted their own set of standards as well. They're not the same as the English version that we're going to be talking about in a few moments. One of the key differences between the two is that, unlike England, they have adopted some of the consequential improvement requirements. So if you are undertaking a small domestic extension the other side of the border, you've now got to consider some of the potential upgrades.
So the English version doesn't have the consequential improvements?
The English version has obviously got the consequential improvements that we previously had, which exempts domestic extensions and smaller commercial extensions as well.
Okay, well, we might come on to that later with the European directive. But a statement by the Welsh Minister for Construction is quite straightforward. I read it from here. He says that the new documents in Wales encourage a minimum standard of loft insulation, cavity wall insulation, and a minimum standard of hot water cylinder insulation. So a 3-point plan rather than a 4-document tome. So is it all as simple as that?
In terms of the consequential improvements, yes, it is. What they've done is they've come out with a simple 3-point plan to ensure that wherever possible you improve the existing dwellings when you undertake an extension or alteration to them. So a really simple, concise, easy plan.
Okay, cool. That's the Welsh for you.
It is.
So these changes have come about to reflect the Energy Performance of Buildings Directive, which came into force in 2013, September 2013. We've got a separate programme on this, ladies and gentlemen, if you'd like to take a look at the back catalogue on NBS TV. But can you just give us a little bit of the background, the synopsis of what it's all about?
Okay, well, it's all part of the move towards 2020 and the adoption of zero carbon technology, zero carbon or nearly zero carbon buildings in particular. What we've already seen introduced is a requirement that consideration is given at the design stage to low or zero carbon technology being introduced into the building. It's probably worth me pointing out that there is no building regs requirement for you to adopt that low and zero carbon technology, simply that you have undertaken the consideration. The software has been updated to ensure that that's actually in place. So as part of the automatic generation of the SAP or SBEM calculation, you'll get that included. One of the other key requirements that obviously we've seen is that local authorities now have to issue a completion certificate at the end of the project, where previously they didn't. Obviously, under approved inspector system, that's always been the case. Okay,
good. That's a nice rounded background. So if we go straight into L1A, which is on new dwellings, headline figure is 6% improvement across the whole building. Again, can you just tell us a little bit about that?
Well, I think the first thing to point out is that 6% is the headline figure. It's not the actual improvement on the actual project that you'll be looking at. So, for example, depending upon the building type, from, say, an individual flat to a large detached house, the 6% figure will vary. You're probably looking more of variation between 3% for the small self-contained flat to something more like 9% if you're actually designing a large detached dwelling. So I think we need to draw people away from the headline figure of 6% and actually take into account the fact that that's an across-the-board approximation, not the specifics of the increase.
Okay, and then there's something called elemental recipe.
Yeah, I mean, this is our attempt to simplify it in the way that the Welsh have simplified it. What we've done is we've realised that the complexity of the approved documents is such that it's almost impossible to understand at the beginning of the design process whether or not you're going to achieve compliance at the end. So you've had to undertake a SAP calculation to get any kind of idea as to whether your design is going to comply or not. Under the new approved document, there is a simplified table, and I use the term simplified loosely, it's certainly not a three-point plan, that sets out a series of criteria. And so long as you follow those criteria, you will be sure that your building will comply when it goes through the system at the end. So what they've done in effect is they've run a series of calculations for a series of building types, and on every case that has passed through at the end of the building.
But those models are over-egged, are they? They're over-contingency.
Of course. I mean, the only way in which you can ensure that that's the case is to ensure that they're over-egged. I mean, we're talking about wall U values of 0.18, for example. To achieve that, you're looking probably at 175 millimetres or more cavity with a mineral wool insulation. It's moving us a lot further forwards away from the traditional build than we've perhaps been used to. So yes, it's a useful tool for setting it out. The other thing I need to point out as well is even though you followed the simple elemental method, doesn't mean that you then don't have to still submit the calculation. It's still a requirement, and the only method by which you can show compliance is through submitting the calculation, the same as we had before. So it's simplified it in that it helps you to have confidence before you start, but it hasn't simplified it in terms of the actual process that you still need to go through.
All right. And then there's this fabric energy efficiency target.
Yes.
FEET. Feet. So that's in the SAP calculations. Just explain, because this is a new thing.
It is indeed. I mean, there are a number of new acronyms to be looking out for. You've got the design fabric energy efficiency, the Duffy, and you've got the target fabric efficiency, or the Tuffy. So you've got to compare your Duffys to your Tuffys under the new system. Cutting to the chase, what is a fabric efficiency standard? What we're actually looking to do is to draw people away, which slightly conflicts with what we said earlier, from the utilisation of low and zero carbon technology at the expense of the fabric. So what we're going to do as we move forwards is we're going to tighten the fabric efficiency standards. So what's actually happened is, on top of the TER, DER that we're used to, we've introduced the T's and F's approach moving forwards. So you not only have to meet the TER, DER standard, but you also have to meet the Tuffy Duffy.
Yeah, okay. Well, look, let me just, as a refresher to people watching, just as a background, the target CO2 emission rate, TER, is the mass of CO2 emitted in kilograms per square metre of floor area per year. The target fabric energy efficiency rate, TFE, is the amount of energy demand in kilowatt hours per square metre of floor area per year. Fabric energy efficiency considers the space heating and cooling demand of a dwelling and is affected by building fabric U values, thermal bridging, air permeability, thermal mass, and lighting and solar gain. The FEE is measured in kilowatt hours per square metre per year and is not influenced by building services. It is a performance standard, meaning that different combinations of fabric specification can be used to attain the required standard. So that's a nice general simplified version, but give us a little bit of the details as to what that might mean in practical reality.
Okay, well, what it means in practical terms is that for a number of years, we've utilised things like solar PV to offset the fabric standard. Now, what we still have to do is we still have to calculate in the same way that we previously had the DER, TER targets, and we still need to comply with those. But you then need to do a separate calculation on top for the fabric efficiency standard itself. So if, for example, we take a plan to increase the U value of the windows, and we use that to offset to have a lesser cavity than the 180 that we mentioned earlier. Because both of those elements of fabric we're trying to offset fabric against fabric, that will still work quite well in the secondary calculation, the fabric efficiency standard. If, however, you take something else, say solar PV or wastewater heat recovery or something of that kind, then because that isn't part of the fabric, if you utilise that to try and offset the wall, you'll find that it's far less effective when you actually run the calculation at the end of it.
Just to be clear, I mean, even though you're half telling me that this is being simplified, On the other hand, it sounds very complicated. So are there software packages available to fit into the existing SAP calcs?
Yeah, indeed. All of the main software companies have been aware of this for some time, and there are a number of commercial packages that have come out which will run both calculations for you. But I say it is important to note that you have to comply with both of those calculations. And people that have traditionally built poor quality fabric or leaky fabric will find that there is an increase above the 6% or 3% or 9% that we mentioned earlier, depending on building type, because of the fact you can no longer do that.
Right.
One of the key changes in the commercial software that's been released is a recognition of the fact that obviously we've got the changes from TERs, DERs to Tuffys and Duffys, but also alongside that we've introduced factors for where the building actually is in the UK. So we're starting to introduce solar requirements that are different if your calculation is done in Cornwall to the one if it's produced somewhere up in the north of England. So all of these factors are starting to affect the way in which the designs are actually done. So there's a number of those changes. One of the other key changes is the way in which the thermal bridges are calculated, and without going into too much detail on that, that's an area in particular that will need to be looked at as we go forward. It's one of the key areas of design which will mean in effect you need to calculate each and every thermal bridge in detail throughout the building if you want to get to a point where the building that you hand over is actually similar to the building that you've calculated. And certainly it was highlighted by the Zero Carbon Hub as probably the single factor that's going to bridge the performance gap between design and as built.
So I suppose we have to comment on the thing you mentioned at the very beginning of the program, the nearly zero energy buildings. So after years of flagging this up, and I think we've had many programs on approved document Ls in the past, well, we talked about 2016 being this halcyon period where zero energy buildings would be brought in. So is this a sign of defeat?
It's a sign, I think, of realism. I think we've finally recognised that there is no such thing as zero energy. Without doubt, almost every building will have an energy requirement of some description in order to service it. If you actually look at what's being proposed, they're looking at minimising that down and providing it through low and zero carbon technology wherever possible. So what this will mean, as we move from the 2013 intermediate step to the 2016 approved documents, we need to now look at the top of the triangle, the infamous carbon triangle that we've discussed on many occasions. It's that bit at the top that's very, very difficult to achieve through on-site, certainly through fabric compliance.
So this is basically saying that boilers are at the top of their efficiency, fabric is pretty, with 175 mil of insulation, you can't get much better. So we're looking at alternative measures.
Well, what we've recognised is that there is a diminishing return on investment once you get to that point. So you then have to start looking a bit outside the box as to how we're going to realistically achieve that, given the fact that there will always be some energy need in every building, even if it's only heating your towel rail. So what we've got to look at is the methods by which we're actually going to achieve that final part of the triangle. Now, there was a separate consultation on this called the Allowable Solutions Consultation, and that looked at a range of options that the government have set out. Now, in terms of admitting defeat in terms of the built environment, certainly we can throw that, because one of the key alternative allowable solutions is a traded solution rather than a built environment solution, which means we can now start looking at carbon offsets, not just off-site, but actually off the book as such, almost like a Section 106 type agreement in place where you're buying carbon credits for the energy use of the building that you're actually producing.
So not only approved inspectors and sustainability consultants, but now we're going to have energy accountants.
Yes, I mean, it does worry me how much we're going to get involved with the stock exchange as we move forwards. One presumes that there will be a series of carbon offset products that are released onto the market. There could well be some form of green bank that the government have in mind that will enable you to offset. But there could be things perhaps that are more tangible for those of us working in the built environment. For example, if you had a street in Liverpool and you upgraded the windows, you upgraded the boilers, you upgraded the insulation in the way in which the Welsh have done in their document, then the offset that you've achieved by upgrading that existing street could be utilised as your allowable solution for the building that you've just created here in England.
Okay, okay. So lots of on-site checks.
Lots of on-site checks potentially required. Also, architects will be used to using the accredited details that they're familiar with. It's worth me pointing out that at this stage, the accredited details don't adopt the same SI values that we have within the approved documents. So you won't be able to automatically use the same ones. Effectively, there's a whole new series of accredited details that will need to be brought to market for you to do that. Otherwise, as I say, you'll either have to adopt the default, which is bad, don't adopt the default, or you'll have to go through the process of employing your SAP calculation person to undertake individual calculations for each thermal bridge, which I say is obviously a much more complex way of doing it.
Let's move on to approved document L2A, buildings other than dwellings. Energy Performance of Buildings Directive again sets out clear requirements on renovation. So again, what's been the impact of that directive and the changes?
There's no sort of major changes in terms of the directive from commercial buildings, other than the point, obviously, that commercial buildings, commercial public buildings will need to comply with the requirements before commercial non-public buildings. So we're seeing targets of 2018 and 2020 for those to be brought into place.
And this kind of headline figure, like we said before, on L1A of 6%, we're looking at, what, 9% or up to 12% even on?
We're looking at a figure of 9%, but that is your across-the-board average figure again. You will find that when you look at the approved document and the software, there are differing types of buildings. For example, there are small warehouse buildings. The increase there is probably around 3%. If you take a large open plan office building, then the increase there is probably more like about 15% than the 3% on the retail warehouse. What's the reasoning behind that? Well, to a degree, when they actually ran the modelling and in the consultation, they found that there was very little scope for the small retail warehouse to actually be able to improve significantly on the standards that they've got at the moment. Whereas the open plan, deep open plan, side lit offices have much greater ability. So that to a degree there's a fudge factor that's been introduced to recognise that the across the board increase should actually reflect the practicality of our ability to improve.
Right. So we've gone through some of the percentages and the differences in that level, but are there any other key differences that you would point out between L2 and L1?
I think probably the key one that I need to draw your attention to is the fact that whilst we've adopted the fabric efficiency standards for domestic dwellings, we've not adopted that within the requirements for commercial buildings. So where we've had the toughies duffies that we mentioned earlier, we don't have that within the SBEM calculation. It's just the previous version, so the equivalent of the DER, TER.
All right, good. And then with the SBEM, there's more notional buildings.
Yeah, as I say, what they've done is they've expanded the range of notional buildings. So, as I mentioned, there are differing types of building. For example, the small warehouse, the larger warehouse offices, deep plan offices, and then whether or not buildings are side lit, top lit. All of those factor into the range of notional buildings that you've actually got. So it does help you actually calculate a more exact calculation that reflects the actual building that you're doing and hopefully therefore the actual energy use afterwards.
Okay. Just one other thing, since I spent many happy hours reading these documents, Domestic Building Services Compliance Guide, heating pipework is now going to be factored in, isn't it? Factoring in the energy losses through pipework in housing.
Yeah, you're quite right. One of the other minor changes that's kind of slipped in under the radar is that primary pipe work within, for example, the common areas of flats now needs to be insulated.
All right. So, is the industry ready for these shifts in Part L?
I think at this stage the industry can move towards it. The big step up will be the next one. I think the thing that the industry is going to have the biggest problem with, as I mentioned earlier, is the thermal bridging concerns. I think the rest of it, we already are able to build 180mm cavities, but we're pushing our luck if we're going to get it much further than that. We're then looking into off-site production techniques. We're looking at true implementation of low and zero carbon technologies. If you ask me as an industry, are we ready for that? I think we're a long way away from it. I think we need to invest in the technology. I think we need to invest in the products themselves that come to market. But most of all, I think we need to invest very heavily in the training, both of the designers, of the building control bodies themselves so they understand it, but most of all of the contractors and the guys actually on site who need to understand the simplicity of something like a mortar joint being installed underneath a window and how that affects the performance of the thing overall.
Very good. Well, thank you very much, Jeff. That's it from us. Another high energy performance from Jeff Wilkinson, as I'm sure you will agree. So until the next time, and with Part L, there's always a next time. We'll see you then. Thank you very much for watching. Bye-bye.
Cheers.
Very good.